primary classifications of rocks based on knowledge and solidification of water lava or magma and rocks. Sediment by weathering of ignition rocks and classification of these gradually deposits in the air. Examples. Similarly, metamorphics is formed from the ignitions or sediment rocks due to the changing in the induced by the heat and pressure, etc. There's a marble and shale from others. Sandstones. These are the primary classifications of the rock is concerned. Properties are very rock. These are general rock classifications. Properties are there. These properties are knowledge of the physical and mechanical properties of rock play an important role in all mining activities, right from the geological exploration up to mineral verifications. It is essential for the design of opening, underground drilling, blasting, strata control in particular. It is important in pit wall stability in open cast mines. So physical mechanical properties of rock uh, play a vital role for the purpose of design of open pit and open undergrounds, drilling, blasting, strata control in particular. It is important of the pit wall slope stability in open cast mines. In the past 3 decades, the production of the scientific information related to rock properties and design and stability of rock um, accelerated rapidly. The rapid growth can be attributed to the number of causes. First, a part of the growth is properly. Generally, consequences of the general increases in the scientific activity that has produced, among other things, theory, instruments, and measuring procedures adaptable to rock mechanics investigations. Secondly, in the field of the mining engineering, as a more accessible, ore bodies are depleted. There is an ever increasing incentive to extract higher percentages of minerals from a deposit and to mine at a greater depth. Both these factors require a more through understanding in the mechanics of the structure of the rock. A knowledge of the strength properties of rocks can be applied to problems of design in mine openings, dam, underground excavations, etc. Various physical mechanical properties which are mostly considered for different aspects of mining are hardness, density, porosity, uh, compressive strength, tensile strength, shear strength, bending strength, permeability, elastic properties, plastic properties, and dynamic properties. Some of the rock properties that influence in the mining activity. Strength and elastic properties for the use of drills and explosive drilling development. Drillability index, which is mostly depending on physical properties used for selecting the best drilling method and norms in the drilling operations. Choice of explosives, nature of the explosives, and its strength properties. Choice of the mission for extraction of the mineral based on hardness, strength properties, abrasiveness, and rock burst and slow stope failure based on strength properties and other mining activities. So permeability is one of the characters of physical property. Measure easy with which fluid will be flow through the porous rocks depending on the number of interconnectivities of porous and fissures. Porous rocks need not be permeable unless pores are interconnected. Highly porous but impermeable. Lab test also two methods of measuring discharge of Q through the specific specimen under constant air pressure over time. Q is equal to Q by quantity by T. Radial flow test, hollow cylindrical specimen prepared by drilling center holes and measuring flow between the outer and inner surfaces. So generally rock type, intact rock type, the value of K, sandstone, granite, limestone, schist. These are the generalized formula for permeability character. So slag durability test is one of the important property of the rock. Slag durability, the moisture content and observed nature and dryability. This will be explained by this simple slag equipment. There will be chips of rock which you go to be conduct slag that will be small size pieces and pour into the with water and a number of times rolling after rolling, dry it and weighing of before and after. So we'll get the slag index of a particular material, particular coal or sandstone or those things. This is a objective. This this test is done in to find out the resistant offered by a rock sample to weakening and disintegrations when subjected to standard cycle of dyeing and wetting in a slag fluid used full water. Appropriate used name of the equipment. mm, Balance as per the requirement 0.01% of sample and a slag durability test apparatus must give 20 revolutions per minute. Oven 105 plus or minus 5 degrees per centigrade and 1 degree. So apparatus used, these things and apparatus are used. The sample preparation. The test sample consists of a minimum of 100 rock lumps, each weighing 40 to 60 grams to give a total samples weight 400 to 600 grams. Rock's lump should be spherical and corner of the rock lump should be rounded off during preparation. Procedure: dry the sample to constant mass by placing it in oven, maintaining at a temperature of 105 plus or minus 5 degrees. Place the sample in the drum of the emission and record the weight of the sample plus the drum at A. Fit the lid with the drum mounted on the drum in the trough while filling the trough with slag fluid to level 20 below the drum axis. Rotate the drum at 20 revolution per minute for a period of the 10 minutes. So this is a sample preparation and rotation of mission. Here is so this is a mission similarly. Remove the drum from the rough and remove the lid from the drum. Dry the drum plus the retained portion of the sample in an oven. Maintain at a temperature of the 105 plus or minus 5 degree behind the weight of the drum plus retained portion of the sample as B. Repeat the steps from the 2 to 5 for the further period of the 10 minutes. Record the weight of the drum plus retained portion of the sample as a clean the drum and record its weight as it. So this is a figure showing the drum. Then slag durability index. The slag Durability index, second cycle is calculated as a percentage ratio of final to initial dry sample weight as a flow follows. ID is equal to rock retained in the drum, total dry weight of the rock. The ID is equal to C minus D by A minus D into 100. Uh, this is the ID for the slag durability index is concerned. Durability classifications, very high durability, um, high 98, 99, 95, 98, medium high durability 95 to 98, 85 to 95, medium durability 85 to 95 to 60 to 85, low durability 60 to 85, 30 to 60, very durability less than. This is the classification based on the very the rock retained 10 minutes of cycle of the water and the drained. The percentage is indicated the durability of the particular rock. The generalized table for the durability test. Index properties are there. Index properties are shown in there. Early identify and measurable used for classification. Unit weight by finding specific gravity of grades after grinding. Granite 26 kilonewtons per meter cube. Marble 27 kilonewtons per meter cube. Limestone 20 kilonewtons per meter cube. Porosity Vs and V into 100. A quality index measure of extension of fissures and cracks. Porosity represents the storage capacity of the geological material. Depending on a particular size of distribution, mineral composition, sorting of grains, degree of compaction of grains, etc. Ignitions 1 to 2%, sedimentary 0 to 90%, reduction with age and depth, sandstone 15%, chalk more than 15%, can be obtained from the specific gravity and water content. Is analytic W by G by 1 plus WG. These are the rock samples using percussion drilling or core drilling, preparation of ISO 9179 to 91979, the box containing the expenses, the bore log, borehole number and location, orientation of boreholes, drilling technique, drilling progress, flush return, standing water level, state of recovery, important of be noted, labeled in core boxes with the site name, pH number, and contract details, labels on lid and samples. Rock core recovery. Laboratory tests, tensions, splits, tensile bridge test, shear, UCC, and triaxial test, flexure beam, bending test, plastic modules by bridge and bending tests, in-situ tests, deformability, PLT, uniaxial jacking, pressure meter, shear strength, and in-situ direct shear test, internal stress, hydraulic fracture, flat jack test, stress relief index. These are the in-situ tests. These are the laboratory tests. For find out, particularly uh, um, strengthening of various rock nature. Natural form solidly. bonded mass of mineral which cannot be easily disintegrated by hand or by the single wetting and drying cycle. Rock progressive fracture, so soils transported distinctions UCS 1 megapascal rock, response of rock to different loads important depending on the rock mechanical properties and geology features. So complexity in the rock analysis. Specimen properties is different from the mass properties, anisotropy and heterogeneous. Time and scale depending upon geological process. Properties of intact rock. The In the beginning of rock mechanics, in the early, more attention has been paid to the intact rock than to the other features of the rock mass. The reason of it, the subject of it's related to the heavily and general mechanics of the solid material. Second, intact rock samples are obtained easily from the drill cores. Testing of the intact rock. Destructive strength test. Uniaxial compressive strength test. Uniaxial compressive strength, Young modulus, Poisson ratio. Triaxial test, Young modulus, Poisson ratio, shear strength, cohesive angle of friction, point load test, indirect tensile strength test, Brazilian test, beam test, direct shear strength test. These are the testing of intact rock. So testing of the intact rock, non-destructive strength test, cement hammer, surface strength, estimation of strength, US wave propagation, detecting of the micro cracks inside the specimen, estimation of the strength, other test, density property, porosity, water content, water absorption, leaking test, water. Compressive strength test is important test for the rock is concerned. The compressive strength of probably the most widely used and quoted rock engineering parameter is concerned. Under uniaxial load conditions, the maximum stress that the rock sample can be sustained referred as a uniaxial compressive strength that can be indicated under C, sigma C. The most useful description of the mechanical behavior of the intact rock is a completely stress strain curve of the compressed strength test. From this curve can be determined the Young modulus, the post peak behavior of the rock material. So this is a testing lab uh, strength test, compressive strength test. This is the failure criteria of the particular rock specimen. For procedure commonly used to determine the compressive strength, the subject is cylindrical specimen to axial compressive loading between the platen in testing mission. Stress value of the failure is defined by compressive strength specimen equal to applied force by initial cross-sectional area of the particular specimen. In addition, the internal factors like mineralogy, grain size, porosity, the external factors that influence the compressive strength test results. Uh, Friction between the platen and the surface, specimen geometry, shape, height, diameter, ratio, size, rate of loading, environment. The recommendations of ISRM committee are as per the standardized cylindrical having a diameter not less than the MX4 are to use preferably. Ratio of height of the diameter is to be 2.5 to 3.0. Other rate are used. Conversion of the test results can be made accordingly. End faces are to be parallel and to be perpendicular to the axis within the tolerance given under 2.2. Rate of loading referable as within the state stress state and 70 to 140. Preferred specimen to be stored prior to test of the 5 to 6 days and environment of the 20 plus or minus 2 degrees and 50% humidity. Following information is to be noted in the report to the compressive testing. Location, method of sampling, kind of geological feature, storage of environmental preparation of the before testing, size of the uh, spacepan, moisture content, external direction load, relative load, rate of loading, identification, capacity and uh, use range of testing number of spacemen, mean, maximum, minimum value of the compressive strength, standard deviation varies. Compressive strength value can be estimated from the results of other testing, prototype testing, strength test, work test. The compressive strength value can be estimated from the results of other test of the also there the protodiagnostic test is indirectly can be calculated test strength, point load test, force displacement curve. Force displacement. This is the one force displacement curve showing here displacement and force elongation of velocity contact pre-existing cracks, crack propagations, existing cracks, coal new cracks propagations. These are showing in the graphically and stress strain curve. The stress strain curve. Here the strain curve, there are three zones of the curves are given here. Compaction zone, a linear zone, failure zone. Stress strain curve. Idealized stress strain curve, elastic preferably plastic. So vertical and horizontal displacement of the specimen and the stress shear failure. Then complete stress strain curve, peak strength and graded in modulus, residual strength, peak axial stress, linear. This is the load acting on a particular specimen. The represented by stress strain curve representations and the failure, the particular one, the how that is stress and strain versus stress by strain versus the strain will be here. This is experimental by done by the 2007 Harrison and Hunson and Harrison experiments. This is one more. A complete stress and strain curve. This is a tangential module. Constant pre-peak religion, zero at peak strength. Sig module, reducing the module street figures. So these are the stress and strain curve samples, how they failure with the applying of the load on brittle end for the ductile materials, how they behave like. Different stress strain karo. High stiffness, strength, very brittle basalt. Medium stiffness, medium strength, medium brittleness, limestone. Low stiffness, low strength, brittle chalk. Low stiffness, low strength, ductile rock salt. Characteristic stress strain karo. Well-known Hungarian rocks. The compression strength is not an intrinsic property. Intrinsic material properties do not depending on the material geometry or the loading conditions used during the test. Because of it is height and the diameter ratio of the specimen is 2 is to 1. Uh, Size effect, larger specimen has reduced comparison strength and brittleness. Shape effect, when the ratio of the diameter to length increases, both the compression strength and the ductility increases. Uh, Determination of the Young's modulus. The Young modulus is defined as a ratio of the stress and strain. It can be determined in two ways. Tangent module by taking the slope of stress strain curve at a given point. The given point is a conventional at stress level corresponding to 50% of the peak stress by taking the slope of the line connecting 2 points and the linear portion of the curve. This line can be anywhere of the linear portion of the curve. The Young modulus, this is also one of the important parameter of the rock. Now point load test. This is a very another indirectly calculated by the strength of the point load strength. The point load test is a conduct in the field uh, an unprepared rock specimen using simple portable equipment. It involves compressing mainly rock piece between the 2 points. The point load index is a calculated as a ratio of the applied load P to the square of the distance between the loading points. The point load test has a number of variations such as a diameter test, Triaxial test, and irregular lamp test. The variation should not be confused with the Brazil test. The strength is correlated with the tensile strength as well as the compression strength because of the predominance of the compressive stress in RM problem. It is observed that for the accurate and consistent results, L greater than 0.7 D in diametrical compression, D by L equal to 1.1 in axial test. So DL by L ratio is regular lamp test. So the point load test is the most common test in the rock engineering. Benefit of it is the size and shape of the specimen should be varied in wide range. Therefore, it can be performed when the cylindrical specimen is not available. That this test can easily be performed on field as well as so it is give results very quickly. The value uniaxial compression strength can be estimated by the point load strength. So the point load test is able to perform the field and laboratory as well as these things. These are the point load test conducting instrument. Point load test, the point load test options. So sample from the surface explorers, sample from the core drilling, determination of the point load strength F in the collapse force is equivalent to diameter of the sample. F by d square is equal to pi f 45d. Loading conditions, axial stress, uniaxial tension. This is a normal force and shear force and different direct shear. Biaxial compression, triaxial compression, polyaxial compressions. So these are the uh, different loading conditions of on specific sample. So please go through this, draw all these things. Right. Tensile strength test. So tensile strength, compression strength means apply. Tensile strength is indirectly calculate the tensile property of rock. Specimen subjected to compression strength when fail in tension, tension failure is also encountered in the mechanical winning of the mineral, drilling and blasting, failure of roof and floor. The most different parts in a tensile test on a rock is in a gripping specimen that to get the uniform tensile stress and for easy in gripping, especially prepared specimens are needed, which again in a difficult and indirect method for the determination of the tensile test have come into the view for the direct test. A cylindrical specimen with the central section reduction diameter may be about the throat to the ratio of the length diameter. Recommendation to the 1.5 to 2 diameter, both ends to the 1.5 to 1.5. The radiation of the curvature of the shoulder part of maybe. For routine testing, however, a cantilever type of test may be used. Uh, Loading of is recommended. An indirect method of test, most widely adopted with a strong practical appeal because of its simplicity, is the Brazilian test or the diametric compression ideas. The cylindrical specimen is taken and subjected to the compression load as shown in the tensile strength of is given. Generalized formula for the Brazilian test is concerned. Different formulas are said. So uniaxial tensile strength test is used for engineering practice. There are two reasons for that. First, it is very difficult to perform. Second, the rock does not fail in direct tension in the seat condition. The tension strength is normal measured by the indirect tension, in which tensile strength is generated by the a comparison load of Brazilian test, splitting test, beam test, bending test. These are the so Brazilian test, yeah, showing here very well. Is indirectly for a calculation of the tensile strength calculations purpose. So this is standardized Brazilian test. The height and diameter ratio of the spacepan is a 1 by 1. So position of the spacepan is in the horizontal. Determination of the tensile strength megapascal. A collapse force N. A diameter spacepan is mm and the height of the spacepan is mm. So that 2 f by pi dh is the generalized formula. Where the core NXI are corrected for this test with the ratio length and diameter from 0.5 to 1.0. Rate of loading about 0.64 centimeter deformation per minute will be satisfactory. To make sure failure organizes into a center, it is recommended that distribution of loading with the cardboard or wood are 0.64 mm thick, 0.01 thick, known as the diameter disc may be used. Other indirect methods to be determined the tensile strength or ring test, indentation test, bending test, or prismatic specimens and discs. However, because of the large seaters of the test results of the different experiments, these are not universally popular. The data collection and listening case tensile test is to be same case of the compression test. So this is Brazilian test experiment is concerned. It have one. Another triaxial test is on rock conducting apply confining pressure to decide volume of axial loading the specimen in the comparisons test mission till failure. The axial load and the confining pressure are increased simultaneously and in such a way that they maintain a hydrostatic conditions until the predetermined test level of the confining pressure is reached. Subsequently, the confining pressure has to be maintained in the predetermined level till failure occur with the axial loading. The three minimum tests need to be conducted at three different confining pressures levels to get the three different failures loads, but testing on 5 specimens are preferred at 5 different levels of the confining pressure and give the more reliable results. So these are the operators of test cells and for triaxial testing mission is indirectly the specimen is inserted in all sides a confining pressure. So hydraulic pump and pressure is applied to under triaxial test is going on here. Let's see the figure. So then procedure is a confining pressure applied by means of hydraulic pump and maintained through the oil filled in the cell. Axial load applied at the constant rate of deformation or loading in the loading mention. Each test provide 1 point peak strength of the failure envelope. Minimum 3 under various confining pressure, more circuit drawn. With increasing confining pressure, the peak failure stress falls increases. The corresponding Morse envelopes drawn. From this is the value of the internal friction angle phi and the apparent cohesion C may be obtained. The cohesion and friction values of the rock material is determined from the best fit line, usually the Morse clone failure envelopes. So determination of the cohesion and friction using Morse circle. This is a very popular drawing of the values of the cohesion and also stress with the tangential phi value. Uh, the values will vary cut it in different places. So from this we have to different values from the failures of criteria for triaxial test is concerned. Then this is an increase in confining pressures. How the minor principal and major principal stresses differences and the axis strain. How this strain will become. Unconfined compressive strength of the rock, the uniaxial compressive strength is the value of the compressive stress at which the spaceman fails. The, the compressive strength is usually obtained by compression test mission. This test is usual conducted in the straight circular cylindrical. Load on a specimen shall be applied continuously at a constant stress rate, such that the failure will occur within the 5 to 10 minutes of loading. For a practical consideration of at least 5 number of tests are preferred. So UCS test under the progressive with the 200 tons capacity compression test missions. The modulus of elasticity and Poisson ratio, both are is also very important. From the uniaxial compressor test, Young modulus of elasticity and Poisson ratio rock specimens are determined. The stress strain behavior till back in captured. The slope of the stress strain curve is basically given the elastic modulus of the specimen. Young modulus is defined as a ratio of the axial stress changes to axial strain rate produced by the stress change may be calculated using any one of the several methods plotted by the stress strain curve. The tangent Young modulus is measured at the stress level, which is fixed based percentage of the ultimate strength. Uh, Young modulus measures from the zero stress to some fixed percentage of the ultimate strength taken general at 50%. Poisson ratio shall be calculated as the ratio of the total diametrical strain to the total axial strain at any given stress level. These are shown here. Uh, this is under pressure sample. It is a more common used test for rock determine its strength, but it is suitable done carefully for accurate results. The samples obtained during the exploration are trimmed as per the requirement. The specimen should be in the cylindrical form, and the length to width ratio specimen should be varying from the 2 to 2.5. The end of specimen should be exactly perpendicular to the axis of cylinder, and end should be flat, smooth, and parallel. The dia of the specimen should not be less than 35 mm. Generally, 45 mm dia preferably as per the ISO 91413 and so and so. The specimen is placed uh, compressions testing missions and subject to the comparisons with the stress rate 0.5 to 1.0 megapascals per second. Note down a peak load value where it is failed and find out strength of rock is below formula, whereas it initially is by area assessment. Ring shear test. Give the shear strength of rock as a function of the confining pressure. In this test, the specimen does not require perfect square or smooth ends. Load applied parallel to the axis of the core. As the load is applied to the plunger, two sets of the complex fracture surface from the along the two planes of the imposed shears. The shear strength is calculated by the P by 2 by where P is the loaded is the area of the cross section of the specimen. So Brazilian test. The Brazilian test is a simple indirect test method to obtain the tensile strength of brittle materials such as the concrete and rock-like material. Due to the simplicity and efficiency, it is the most common used laboratory test method is the geotechnical investigation of rock. In this test, a thin cylindrical disc is diametrically compression to failure. For typical loading figures are shown in the figure. And then the instrument is useful for testing specimen from the 50 mm to 100 mm and the thickness of the after diameter. The specimen is held in circular jaws. This is primarily similar to the compression machines and consists of the small load frame have stud base with the two vertical. The instrument is usually testing uh, the maximum point is also provided long edge. The 50 mm decimal is provided. The instruments can be used in the field also. So these are the UTM. The Brazilian test is a disc shaped specimen and the rock is loaded by two opposing normal strip load at the disc primary. The specimen diameter shall be preferably not less than NX core size 54 mm or at least 50 and 10 times of the average grain size. The thickness diameter ratio should be 0.5 to 0.6. The load is continuously increased at a constant rate of until failure of the samples occurs within the few minutes. The loading rate depending on the material and may from 10 to 15 kilonewtons per minute. At the failure, the essential strength of rock is calculated as follows. 2p by pi dt 0.36 to pi by d. The p is the load at failure. Diameter of the test specimen mm. Thickness of the test specimen measured at the center. This is also called a flexure test. The beam rock spacepan is subjected to bending till failure occur. General 4 points flexor loading system is used. The bottom surface of the beam supported at 2 points, one near each end. The top portion of the beam is loaded at the third point. The system procedure pure bending in the middle third of the beam. The flexure strength modulus of sculpture is given, where P is the load, L is the length, specimen D is the diameter specimens. In situ test of the rock, limitation of laboratory test, wrong extrapolation of one behavior of rock mass, sample disturbances, scale and time dependent. In situ test performed especially for determining the in situ rock stress and deformability shear strength of the rock mass permeability, limitation of the in situ test, high and non-uniform strain rate, no control over the drainage condition, expensive and time consumption, purely defined by boundary conditions affected by the site conditions, limitation. So in situ rock test, use of the compact and simple equipment, reduction cost without comparing test quality. Influence area must represent the average rock behavior. Loading condition must be neat and actual bite speed conditions. So these are the popular tests you have to. So shear strength and general deformability, internal stresses. So shear strength test is one of the in-series test. Test in the coming classes you can go to explain this shear strength is concerned. Uh, Equipment for cutting encapsulation test block, rocks or drilling hammer, choose it framed, appropriate dimensions of rigidity, expanding polystyrene test sheeting, shear box. So these are the shear strength is concerned. So well, these are the different properties of the mechanical properties of the rock we so far learned. And indirectly, we can calculate by the compressive strength how to calculate it, tensile strength how to calculate it, point load test how to calculate shear strength. That is coming to class, we can explain. So well, I hope you are enjoyed today class. Thank you.